Hey geometry students, today what we're going to look at is section 2.2 and we're going to be looking at something called conditional statements, something you've probably seen in your science classes before. A statement that has a hypothesis and a conclusion is called a conditional statement, and we're going to be writing them in something called if-then form. But anyway, here are some objectives. We're going to identify, write, and analyze the truth value of conditional statements. And then we're going to write the inverse, converse, and the contrapositive of a conditional statement. So let's get started. Well, here you see our vocabulary, which I just mentioned in our objective, most of the vocabulary words that we are looking at. But here are a couple of others. We saw conditional statement, hypothesis, and conclusion. We're going to look at something called the truth value, and then negation, converse, inverse, contrapositive, and something called logically equivalent statements. So here are a couple of definitions right off the bat. A conditional statement is a statement that can be written in the form if something, then something, or if P, then Q. Looking at our Venn diagram here, our statement, our hypothesis is going to be inside our conclusion. Okay, for it to be true anyways. This is how it's going to look. And then hypothesis is the part of the conditional statement that is after the word if. And then the conclusion is part of the statement that is after the word then. Okay, so by paraphrasing a conjecture as an if-then statement, you can quickly identify its hypothesis and conclusion, and that's what we're going to look at next. Okay, so let's look at this example. We are identifying the parts of a conditional statement. So we're going to identify the hypothesis and conclusion of each of these statements here. So we have, if today is Thanksgiving Day, then today is Thursday. So this portion right here, I said, this part of the statement following if, that is our hypothesis. And then the word then and thereafter is our conclusion. Okay, so that's how I'm going to label these. A number is a rational number if it is an integer. Well, the statement following if, that is our hypothesis. So that makes the other part of our statement the conclusion. So this can be written as if a number is an integer, then the number is a rational number. So we can restate these in its if-then form. All right, let's look at this last one. A number is divisible by 3 if it is divisible by 6. So where's the if part? Right here, that is our hypothesis. And then this portion left over, that is our conclusion. I hope you all understand what I'm referring here. So if you don't, please ask questions about this in class. All right, writing math. We're going to be looking at P's and Q's a lot. Whenever we look at something called truth tables in class, we're going to be writing a lot of this in P and Q form. But here you can see that our if-then statement can translate in many ways, or it has equivalencies in many different ways. So if P, then Q can also be written as if P, comma Q. Same goes here, but backwards. Q if P. That means the same thing as if P, then Q. All right, this one also, P implies Q. Same. P only if Q. Again, all of these statements mean the same thing as if P, then Q. I'm just going to read this. It says, many sentences without the words if and then can be written as conditional statements. To do so, identify the sentence's hypothesis and conclusion by figuring out which part of the statement depends on the other. So once you identify the hypothesis and the conclusion, you can rewrite just about any statement in an if-then form. That is what this is telling us. Okay, so in this example 2, what we're going to be looking at is writing statements in a conditional statement form, if-then form. So we need to identify the hypothesis and conclusion to do that. So here we go. So I'm going to say an obtuse triangle is our hypothesis. I know this because I've just gotten good at it. Has exactly one obtuse angle. So we're going to write this in some if-then form. This is how I'm going to say, if a triangle is obtuse, so an obtuse triangle, so if a triangle is obtuse, then let's look at the conclusion part of this. It has exactly one obtuse angle. There you go. That is our statement in if-then form. Let's look at another one. So again, I'm going to write this out, or draw these, underline this portion, and then this portion. So R acute is our conclusion in this statement. So two angles that are complementary are acute. And so writing this in if-then form, I'm going to state, if two angles are complementary, then they are acute. Hopefully that one made a little bit better sense than the last one. But there is our if-then statement. Alright, so conditional statements, they have a truth value of either true or false. It is false only when the hypothesis is true and the conclusion is false. I know this doesn't make sense, but we'll be looking at some truth tables and discovering their truth values later on. And it says, to show that a conditional statement, I'm reading right here, is false, you need to find only one counterexample where the hypothesis is true and the conclusion is false. All right, in this this third example here, we're analyzing the truth value of a conditional statement. So we're going to determine if the conditional is true. If it's false, we're going to give a counterexample. Let's look at this. If this month is August, then the next month is September. Well, September always follows August, so this is true. And that's all we need to state, that it's true. We're not going to prove this statement here. Now let's look at this next one. If two angles are acute, then they are congruent. Well, this is going to be false. And there are many, many counterexamples that we can look at. But here I'm going to write two acute angles. What if we looked at 60? That's an acute angle. And state another acute angle. These are two acute angles, yet they are not congruent to each other. Okay? So there we go. We have our counterexample. Okay, this last example about analyzing truth values of conditional statements states, if a number is odd, then it is divisible by 3. Well, again, this is going to be false because there are many, many odd numbers out there that are not divisible by 3. So just state one. So what if we say our number equals 5? Can we divide 5 by 3? No, we cannot. So there is our counter example. So remember, if a hypothesis is false, the conditional statement is true. I know this doesn't make sense, but if anytime you have a hypothesis that is false, no matter what the conclusion is if it's a false conclusion, then your truth value is going to be true. We'll look at truth tables more to maybe give you a better visual idea of that in class. But here, one thing I want to state that is on this page is something about negation. The negation of a statement P is not P. So whenever in a statement, if you are saying, if this is true, then you're going to change it to, if this is not true. Okay? Going to be putting a not in there. That's what negation means. The negation of a true statement is false, and the negation of a false statement is true. So whenever we negate things, we just turn it to its opposite. Okay, on this page, we're going to look at the conditional statements and how they relate to other sorts of statements that we're going to be looking at. So a conditional statement, we've already looked at that. It's in if P then Q form. And P is our hypothesis and Q is our conclusion. And then for this one called the converse, what we're going to do to make that statement is just swap our P and Q values, swap our conclusion and our hypothesis, and that is the converse statement. Okay, again, from the original statement, the conditional statement is how you're going to form the next two also, is we're going to, for the inverse statement, we're going to negate the hypothesis and conclusion. So it looks like this right here. We're going to say if not P, then not Q. And then the contrapositive is kind of a combination of the inverse and the converse put together. So we're going to swap the hypothesis and conclusion, and then we're going to negate both of them too to get if not Q, then not P. Okay, so let's look at some statements and making them into the inverse, contrapositive, and converse. Okay, so what I have here in this example is a statement, a conditional statement, something that is in if-then form already. And we're going to write the converse, inverse, and contrapositive of that conditional statement. So here we go. So here's it, our conditional statement. The blue is our hypothesis, the red is our conclusion. So it already has what needs to be swapped out or what needs to be negated highlighted here for you. The converse, remember, we swap the hypothesis and conclusion, and we end up with if an animal has 4 legs, or 4 paws, not legs, then it is a cat. So there we go. There's our converse. We swapped it. Now, whenever you make the converse, inverse, and contrapositive, make sure it makes sense, okay? We're not going to say, just completely swap it out and say, if it has 4 paws, then it is a cat or something like that. Make sure our statements actually make grammatical sense, okay? So inverse, we negate both the hypothesis and conclusion. So we're going to say if an animal is not a cat, then it does not have 4 paws. Notice I didn't just throw the word not in there without making it have grammatical sense in this conditional statement, or this inverse statement, sorry. Okay, the last one, contrapositive. It's the converse and inverse put together. So we're going to swap the hypothesis and conclusion and negate them. So what I'm going to do with this one is I'm going to take this statement right here and negate both of our hypothesis and conclusion. So here we go. I'm going to say if an animal does not have four paws, then it is not a cat. I know many of these statements probably are false, but it doesn't matter at this point. We're not trying to tell what is true and what is false. Okay. Okay, this last thing I want to tell you is something called logically equivalent statements. It says related conditional statements that have the same truth value are called logically equivalent statements. A conditional and its contrapositive are logically equivalent, and so are the converse and inverse. So what I'm going to say here is wait until the next day. I will show you in class what it really means for statements to be logically equivalent. We're going to do something called truth tables in class, and I think this will make maybe just a little bit more sense to see it in the truth table form. Okay, well, that's all I have for everybody. I hope you'll have a good night. Bye, everybody.